Hello there, it's me again. Today I want to show you how I set the correct extrusion temperature on my German RepRap Neo 3D printer. Use a CAD modeling software to sketch up a cuboid and convert it into a STL or an OBJ file. I used the Creo parametric student version, but you can also use other free programs or get the file on my thingiverse link. Make sure your cuboid is 100 mm high and 25 by 25 mm in base area. Import the STL or OBJ file into Repetier host. Now you got to make the necessary adjustments in your slicing software. It's vital for the following steps that the speed is already set correctly. If you are happy with your current speed settings, leave them as they are. If not, first do a speed calibration and then the temperature calibration. When you buy a spool of filament, the producer of that spool supplies you with a temperature range in which the filament is to be printed. My spool's temperature range is set to be between 180 degrees Celsius and 210 degrees Celsius. Therefore, you go into your slicing software to filament settings and set the extruder temperature of the first and the other layers to 210 degrees Celsius. Go then to print settings and layers and perimeters. Note down your layer height on a spare piece of paper. Set the number of vertical shells to 1 and the number of horizontal shells of top and bottom to 0. Go then to Infill and set at Infill the fill density to 0. In that way you will now just print the cuboid's outer shell. Press now the slicing button. Your cuboid gets sliced and you'll see the G-code. Have you noted down your layer height? This is important now. We now want our printer to decrease the extruder temperature every 10 mm by 5 degrees Celsius. You can either do that manually or use the G-code editor to insert G-code commands. For that we use, for example, the G-code command M104S210 to set the temperature to 210 degrees Celsius in a certain layer. Now we have to find out in which layer to insert those commands. If we want to find out how many layers there are in 10 mm of our print, we'll have to divide print height by layer height, or we use the G-code editor. The G-code editor displays the overall number of layers of the cuboid. If we want to print 10 stages of different temperatures, we'll have to divide that overall number of 666 layers by 10, which equals 66.6 and therefore about 67 layers. Hence, we will have to insert that command M104S something something every 67 layers as demonstrated in the video. After editing the G-code, you can start printing the cuboid. Here is a fast motion of the printing process. The first few layers will look extremely blotted. The further the temperature decreases though, the better the layers are neatly and accurately printed on one another. Hence the quality of your print increases. If the parameters are starting to show gaps, the extrusion temperature is too low. Increase the temperature by 5 degrees Celsius and watch whether this gapping continues. If so, further increase the temperature. After your cuboid is printed completely, you'll have to examine it in order to determine the perfect print temperature. The perfect print temperature is high enough so that the material is properly melted and low enough so that the material is neatly put on the print. Therefore, you will have to determine the lowest layers where no impurities occur. This is your perfect print temperature. In my example, I use different steps for the different temperature decreases. At a temperature of 186 degrees Celsius, the layers began to look neat. The best layers, showing no impurities whatsoever, have been printed at a temperature of 177 degrees Celsius, so this is my perfect extruder temperature now. Repeat this process from that temperature at which the layers began to look neat, and choose a smaller rate like 1, 2 or 3 degrees Celsius per 10 millimeters. Remember to calibrate the perimeter again to achieve full accuracy. Yeah, that's basically it. I hope you enjoyed watching my video. If you have other methods and ideas how to determine the perfect print temperature, if you want me to do other videos on calibrating a 3D printer, or if you liked that video or disliked it, just leave some comments for me. Thank you very much for watching. I hope to see you again on my channel, and take care.